Science and technology. Scientific study. Fundamental and derived units and unit analysis. 1. Give reasons. A. Unit of work, joule, is derived unit. Why? Ansh. The unit of work, the joule, is considered a derived unit because it is derived from fundamental units. Work is defined as the product of force and displacement, where force is measured in newtons, N, and displacement is measured in meters, M. By multiplying these two fundamental units together, we obtain the derived unit of work, which is the joule, J. B. V2 equals A does not exist. Ansh. According to dimensional analysis, equations must be dimensionally consistent, meaning that the dimensions on both sides of the equation must be the same. In the equation V2 equals at V. Velocity, dimension of length/time. U. Initial velocity, dimension of length/time. T. Time, dimension of time. The dimensions on both sides of the equation. Left side, V2 equals length/time 2 equals length 2/time 2. Right side, at equals length/time, time equals length. The dimensions on the left side, length 2/time 2, are not equal to the dimensions on the right side, length. Therefore, the equation V2 equals at is not dimensionally consistent, so we can conclude that this equation does not exist in physics. 2. How to check the unity of unit in an equation. Explain with examples. Ansh. To check the unity of units in an equation, perform dimensional analysis. Identify the variables and their respective units. Write down the dimensions of each variable. Analyze the dimensions on both sides of the equation. If the dimensions on both sides match, the equation has unity of units. This ensures mathematical and physical consistency. Example, in the equation D equals at plus half, at 2, the dimensions of length on both sides indicate unity of units. 3. Neve asserted that the formula for the power is P equals mv2 and the formula for the pressure is P equals mv/A. Check the validity of the formula given by Neve by using the unit dimensional analysis. Let's check the validity of the formulas provided by Neve using unit analysis. Formula for power P equals mv2. Dimensions: P, ml2t3 mass times length squared divided by time cubed. M, mass. V, lt1 length divided by time. Calculating the dimensions on the right side. mv2, mlt2 mass times length divided by time squared. The dimensions on the right side do not match the dimensions of power, P, so the formula P equals mv2 is not valid. Next, formula for pressure, P equals mv/A. Dimensions: P, ml1t2, mass divided by length squared times time squared. M, mass. V, lt1 length divided by time. A, l2 length squared. Calculating the dimensions on the right side. mv/A, ml2t1 mass divided by length squared times time. The dimensions on the right side do match the dimensions of pressure, P, so the formula P equals mv/A is valid. Based on the unit analysis, the formula P equals mv2 is not valid for power, while the formula P equals mv/A is valid for pressure. 4. Prove that the unit of electrical resistance is ohm. equals kgm to S3A2. Model question. F to prove that the unit of electrical resistance is ohm. Ohm equals kg square meter S dash cubed A dash squared. We can use the equation that relates resistance R, voltage V, and current I in an electrical circuit. By Ohm's law, R equals V, I. Now let's analyze the units involved in this equation. Units. R, unit of resistance, ohm, ohm. V, unit of voltage, volt, V, equals. I, unit of current, ampere, A. Let's break down the units into their fundamental dimensions. V, ml square T dash cubed A dash superscript 1 mass times length squared divided by time cubed times current. I, A, current. By substituting the units into the equation, we get R equals V, I equals ml square T dash cubed A dash superscript 1, A equals ml square T dash cubed A dash squared. Therefore, the derived unit of resistance, ohm, is equal to kg square meter S dash cubed A dash squared, as the dimensions match.